Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these problems based on the concepts of second derivatives. So we have to find the second derivative of each of the following. So we are given these four equations. So let's start with the first one. Now the second derivative is the derivative of the first derivative. So the first step in finding the second derivative is to find the first derivative for each of these equations. Now the first one is f at x equals 2x over x plus 1. Now this is a rational function, so we can find the first derivative of this function using quotient rule. So as per the quotient rule, so the first derivative will be so prime of f at x equals, so we start with the derivative of the numerator, which will be 2 times the denominator, which is x plus 1, minus the numerator expression 2x times the derivative of the denominator, which will be 1 plus 0 over the square of the denominator, which will be x plus 1 square. Now we can simplify the numerator by distributing the 2 in the parentheses. So we get prime of f at x equals, so 2x and then plus 2. Now in the second part, 1 plus 0 is 1. So 2x times 1 is just 2x. So we just get 2x in the second part over x plus 1 square. Now we can simplify the numerator by combining like terms. So 2x and negative 2x will cancel each other out. So we are left with prime of f at x equals 2 over x plus 1 square. Now we have to find the derivative of this first derivative to get the second derivative. So we'll write that as the double prime of f at x. Now since the first derivative that we got is a rational function, so we should use quotient rule again to find the second derivative. So we'll start with the derivative of the numerator, which is 0 because 2 is a constant, times x plus 1 square, and then minus the numerator expression times the derivative of the denominator. So for that we'll have to use chain rule. So the derivative of the outer function, which is the exponential function with exponent 2, so we'll have to use the power rule. So 2 times x plus 1 and then exponent 2 minus 1 times the derivative of the inner function x plus 1, which will be 1 plus 0 over the square of the denominator. So that will be x plus 1 square and then square outside. Now we have to simplify this expression. So we get double prime of f at x equals, so 0 times x plus 1 square will become 0 because 0 times anything is 0. And then in the second part, we'll have 2 times 2, which is 4. And then 1 plus 0 is just 1. So 4 times 1 will just be 4. So we'll get negative 4. And then times x plus 1 exponent 1, but we don't write 1 as an exponent, over x plus 1 exponent 4, because in the denominator we'll have to use power on a power law of exponent. So we do 2 times 2, which is 4. Now we have x plus 1 in the numerator and x plus 1 in the denominator. So we can cancel out the x plus 1 in the numerator and one of the x plus 1 in the denominator. So we are left with this negative 4 over x plus 1 cube. So this should be the final answer for the second derivative of the first function. So now we can find the second derivative of the second one. Now again we'll start with the first derivative. So we'll start with y prime equals, now the derivative of the first term x squared will be 2x. Now for the second term we'll have to first move the x squared to the numerator, so that will give us x exponent negative 2. So we can show that step. So first we can simplify this expression. So we can rewrite this as y equals x squared plus x exponent negative 2. And now we can find the first derivative. So y prime equals, so for the first term we'll use the power rule, and then an exponent 2 minus 1 plus, now we'll use the power rule again, so we'll move the exponent to the front, so negative 2, and then x exponent negative 2 minus 1. Now we can simplify this expression, so y prime equals 2x, so the exponent is 1, but we don't write 1 as the exponent, and then we do negative 2 and then x exponent negative 3, because negative 2 minus 1 is equal to negative 3. Now we can find the derivative of this equation, and that will be our second derivative. So we'll do y double prime equals, so the derivative of 2x will just be 2, because x has a exponent 1, so we move 1 to the front, and then x exponent 1 minus 1, so x exponent 0 is equal to just 1, and then minus, so we'll keep the 2 as the coefficient and we'll use power rule, so negative 3 will move to the front, and then we'll subtract 1 from negative 3. So we get y double prime equals 2. Now negative 2 times negative 3 is plus 6, and then x exponent negative 4, which can be simplified to y double prime equals 2 plus 6, and we can move the x term to the denominator to make the exponent positive, so we get x exponent 4. So this should be the final answer for the second derivative of the second equation. Now we can analyze the third one. So the third one is given as g at x equals square root of 3x minus 6. So the first step is to change the radical into a rational exponent. So we can rewrite this function as g at x equals 3x minus 6 and exponent 1 over 2. Now we can find the first derivative by using the chain rule. So this function has an inner function 3x minus 6, and the outer function is the exponential function with the exponent 1 over 2. So the first derivative will be prime of g at x equals, so we start with the derivative of the outer function, and for that we'll use the power rule. So we'll move 1 over 2 to the front, and then times 3x minus 6, and then the exponent will subtract 1 times the derivative of the inner function, and the inner function is 3x minus 6, so the derivative will be 3 minus 0. Now we can simplify this expression. So prime of g at x equals, so 3 minus 0 is 3, so we'll multiply half by 3, so we get 3 over 2, and 3x minus x, and then exponent, and half minus 1 is equal to negative half. So this is the first derivative of the function g at x. Now we have to find the second derivative, which will be the derivative of this first derivative. So the double prime of g at x equals, so we'll have to use chain rule again. So 3 over 2 is the coefficient that will stay the same. So we'll start with the outer function. So the derivative of that will be, so we'll move negative 1 over 2 to the front because we're using the power rule, and then we'll subtract 1 from the exponent, so negative 1 over 2 minus 1 times the derivative of the inner function, and that will be 3 minus 0. Now we can simplify this expression. So 3 over 2 times negative half will be negative 3 over 4 times 3x minus 6. Now negative half minus 1 is equal to negative 3 over 2, and then times 3 minus 0 is 3. Now in the next step we can multiply negative 3 over 4 by 3, and we'll get, so the double prime of g at x equals negative, so 9 over 4, and we can move 3x minus 6 to the denominator to make the exponent positive. So 3x minus 6 and exponent 3 over 2. So this should be the final answer for the derivative of this function g at x. So this is the second derivative. Now we can analyze the last one. So we are given the function h at x equals cube root of x exponent 5. So the first step is to change this radical into a rational exponent. So the first step is h at x equals, so we can rewrite this as x exponent 5, and then parentheses 1 over 3. So cube root can be written as 1 over 3 as a rational exponent. Now we can combine these exponents by using the power on a power law of exponent. So we multiply 5 by 1 over 3, and we get x exponent 5 over 3. So now we can find the first derivative. So prime of h at x equals, so we'll start with the power rule. So we'll move the exponent 5 over 3 to the front and subtract 1 from the exponent. So now we can simplify this expression. So prime of h at x equals 5 over 3, and then x exponent. So 5 over 3 minus 1 is equal to 2 over 3, because 1 can be written as 1 over 1, and the common denominator will be 3. So we get 5 over 3 minus 3 over 3, which is equal to 2 over 3. Now we can find the derivative of this first derivative, and that will be the second derivative. So double prime of h at x equals, so we'll have to use the power rule again. So 5 over 3 is the coefficient, so it will stay the same, times 2 over 3, and we'll subtract 1 from the exponent. Now we can multiply the fractions. So the double prime of h at x equals, so we multiply 5 times 2, which is 10, and then 3 times 3, which is 9. and in the exponent we do 2 over 3 minus 1, so which is equal to negative 1 over 3. Because the common denominator will be 3, so we'll get 2 over 3 minus 1 over minus 3 over 3. Now we can move the x term to the denominator to make the exponent positive. So we get 10 over 9 and then x exponent 1 over 3. So this should be the final answer for the second derivative of this function h and x. So these are the steps you have to keep in mind to find the second derivative of equations like these. So we first have to find the first derivative and then the derivative of the first derivative to get the second derivative. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.